Oh, I can see us on my iPad, so I think we should be live.
Hello, Sergio.
Hi, everyone.
Hey, Cedric.
Many familiar faces in the comments. Let's give people another 1 or 2 minutes to join. In the meantime, you can maybe introduce yourself, say hi in the chat. We are very happy to see you all.
Hey, Mohamed, Johan, Eugene. Yeah, this is filling up way quick.
I like Johan's comment saying sounds like Alina. So maybe they could hear us before they could see us.
And there's Olya.
If you ever thought who makes the most amazing GraalVM org website and all the cool pages and docs, that is Yevhen and Oля, who are now in the comments. So if you like our website design as much as we do, you can tell them in the comments how much you appreciate their work.
100%.
Okay, 6:31 in Central European time zone. What do you think, Fabio? Maybe we can begin.
Yeah, let's go. Let's do it.
So again, hi everyone. Today we are happy to talk with you about GraalVM for JDK 23 and all the cool features in this new release. My name is Alina and I'm a developer advocate for GraalVM.
Hello, and my name is Fabio Niepaus. I'm a researcher on the GraalVM team at Oracle Labs. We're excited to talk about the new GraalVM release. There's a bunch of cool new things, including new features for native image, the Graal compiler, and Graal languages.
And we have many, many updates. We have a bunch of demos, and we have 2 release blog posts to go through. So let's see if Fabio and I can make it in under 1 hour.
No, tough.
Let me get my screen. As I'm setting up, you can also let us know in the comments if you were also in the Java stream. We were also there. There were many cool updates. So let us know if you were also there and what was your favorite update from the Java stream. With that, let's talk about GraalVM. So today we are releasing GraalVM for JDK 23. As you might know, we are releasing on the same day as Java, so you can get access to all the latest Java and GraalVM features in one release. If you want to have a new JDK 23 distribution, we recommend that you get GraalVM, and this way you can get all the latest features in one place. And as we are showing all this thing to you, all those artifacts are already up. You can also read the release blog post, and updates on the website are available as well. So all that is already there for you to try out.
Our friends at JetBrains actually already posted on Twitter that it's available in IntelliJ. So big shout out to our friends at JetBrains. I know lots of people are excited about SDKman, and we love SDKman too. It will only take a couple of hours, but I'm guessing at least like tomorrow, SDKman will feature GraalVM for JDK 23. Alina, why don't you zoom in a little bit on the release blog post?
Yeah, good point. In the meantime, as you were talking about SDKman, I just wanted to say that here you will have the SDKman installation command. It's coming up soon. And I agree with Fabio, SDKman is amazing. It's our go-to tool to manage your JDK installations. And already got DMs from our friends such as Josh Long asking, is it on SDKman yet? So everyone is waiting for that. Yeah, we are also very excited.
Yeah, but it's not the only way. There's also GitHub Actions. You can use that today. Container images, there are script-friendly URLs, and of course, Paketo build packs if you're building Spring applications. I see more people coming in. Hi, Aisha. Hi, Wolfgang. Greetings to Frankfurt. I'm guessing Wolfgang is in Frankfurt at the moment. Lots of familiar faces, a new one. This is good. So let's go back to the release blog post.
So let's talk about the release blog post. And yes, I'm zooming in. So this is our update blog post. And first, let's talk about the JDK and native image features. So for the JDK, we have a new release that is based on JDK 23. We have implemented several new jobs. And if you want to use new preview features, you can use them in GraalVM as in any other JDK. Specifically, if you're using preview features, you can pass this flag enable preview to either GraalVM as JIT or the same thing in native image if you want to give those new preview features a try. But just a reminder that GraalVM is also a JDK. So if you want to run your applications on GraalVM as a JDK with a highly optimizing Graal JIT, you can do so. And the migration there is very easy. So give it a try. And there is no reason for you not to use GraalVM as your JDK 23 and get access to all the features. With that, though, let's talk about native image. And the first update here is that we want to talk about performance. You know, we love performance a lot. We work on a compiler, so performance is one of our key topics of interest. And here we are sharing a benchmark of a Spring path cleaning application. This is a good, I would say, standard benchmarking app if you want to showcase something that is, a web app, reads and writes data, something that you probably write for your production workloads. Path cleaning is a good benchmark to showcase that. And here we have new numbers for the 23 release. And this is also benchmarked on ARM-based machines. So a few observations here. As you can see, peak throughput here is on par with executing on the JVM, so on GraalVM CE in this case. And peak throughput is on par. We always want to give you the best possible performance with native image. But if you pay attention to other metrics, such as memory usage, you will notice that on native image, memory usage is much lower. In this specific case, 1/3 lower. And this also means that if you care about how efficiently you're using your machine, your machine's resources, you can get more value, more work done with the same resources if you're using native image, because native image compiles code ahead of time, so it doesn't need to do as much work as the JVM does at runtime. So here on all the metrics that you can possibly care about, you can see that native image is doing very well. Even when it comes to latency, if you maybe have some strict SLAs to meet, latency is also very good on native image. Give it a try.
What's actually quite surprising, I know that I'm comparing those numbers, like memory usage here, what we're reporting is max RSS, resilient set size. So that is essentially the peak of memory usage, real memory usage on your system. And if you're looking down below in the caption, we actually limit the heap size to 512 megabytes. So that means we are allowing the Java heap to grow to 512 megabytes, but there's more in the process, like a JIT compiler, a garbage collector, metadata, profiling information, lots of other things. If you're looking at the statistics, it's actually using 910 megabytes, right? So you're setting 512, it's actually using up to 910 megabytes, and that's additional overhead. And the overhead is much smaller if you're going with native image.
Yes, thank you, Fabio. And staying on the performance topic, we want to introduce new feature. And I know that this is something that many people in the community are excited about. We had many conversations about this with our community members. And that is that we now have new compacting garbage collector. And this applies to both Oracle GraalVM and GraalVM Community Edition. And its main intention is to reduce the memory usage, to reduce, again, the max RSS of your process. And this can be in particular beneficial for applications that you want to set up to run with smaller heaps, or maybe you're deploying to resources-constrained environments. But also overall, if you want to make sure that you are never using more memory than you possibly could, this is a good option to go. And another interesting fact here is that there is no performance penalty to pay. So you can reduce the max RSS, but still have the same performance. And I think this is really good news. As an example here, we have another benchmark, which is the Scrabble application. And here memory is reduced, specifically RSS is reduced by 20% by switching to this new compacting GC. So I think this is really good news. And I know specifically many people were waiting for this. So again, let us know how you like it. Let us know if you will give it a try. I also wanted to take a look at the comments and see what is going on there.
Yeah, so someone is asking about the tracing agent and whether that has changed. Well, we keep improving the tracing agent for sure. But for JavaFX applications, things should usually work. They don't need any additional metadata. The one thing that you need to keep in mind is, of course, that JavaFX is very heavy on modules, and that can sometimes be a bit complicated when you're setting up a project. But I'm not aware of those issues, so feel free to open a ticket, let us know what the problem is, and we can take a look. Then there's another question from FreeQ. Is there any improvement on compile time? Well, the Graal compiler is production ready for quite some time now, so and we keep improving it for sure. We've been made aware of some bugs in the past where compilation is a bit slow, and we fix those. So if you have any examples where the compile time is not ideal, again, please share that with us so we can take a look. But from what I know, the compiler is in pretty good shape and quite fast.
But also,
So
Fabio, I think this might be about native image. I mean, the person asking can let us know if that's what they meant. I can only assume maybe they meant native image compilation times. And for that, yes, we have some updates. And we also will compile a native application live in a bit. So you can let us know if the build is faster. But overall, we are working with our release to make the builds faster and also less resources consuming. And there is another big update about this towards the end of the stream. But stay with us, and we will show you an update on that front as well.
Okay, then there's more questions from Johan, whether we keep supporting other GCs like G1. Well, Oracle GraalVM supports G1. That's the same garbage collector that you get on Hotspot. So you can use that today. It's actually a lot of work to maintain and keep G1 up to date with an Oracle GraalVM and native image. So that's not available in the community edition, although the new compacting GC is. And of course, the community is free to contribute more garbage collectors as we go. What else is there?
And there is a nice comment about, I think, improvement for running applications on more resources constrained environments. So I guess this applies to the new GC. People are excited, and so are we.
Yeah, and you were right. FreeQ was actually asking about native image compilation time. So we'll get to that. Not in this release, but we'll get to this.
Yeah, just one last comment here. So again, from Johan saying that native build times were faster and more efficient for 20C release. I think so as well, but we will get there in a second. Okay, cool.
Let's move on.
Go. Yeah. So this was an update for the new GC available in native image. Now, again, staying on the optimizations topics. So you know that there are multiple optimization options and scenarios in native image. One thing you can do is you can optimize for the best peak throughput and set the maximum optimizations level, or you can optimize for a quick build as you're still developing your application. And now, additionally, we have a brand new optimization scenario and option, which is -OS. And this is optimized for size. So for a while, we had users asking us to make this available in native image out of the box. Maybe you want to have smaller executables to have an option to optimize for this. And this was possible previously with external tooling, but now this is also a built-in option for native image. And as an impact for it, you can see this application. This is a Spring Boot application. And here with -OS, the size of it is reduced by 1/3 approximately. So again, if you want to target image size specifically, maybe you don't care about other performance metrics so much. Maybe peak throughput is not your main concern, but you specifically want a smaller executable, -OS will be your way to go. Okay, and in other news, so in the Java stream, if you were with us in the Java stream, and I see some people in the comments saying that they came from the Java stream. So in the Java stream, we briefly mentioned our SBOM support and the updates that are coming in this release. So you might know that previously we also had support for SBOM in native images, but previously it was always an embedded SBOM. So you could have included a software bill of material in your native image, and it will be embedded inside the native executable, and you could have scanned it with, let's say, vulnerability scanners. But now we have a new way to use SBOM in native image, and that is to make it available on the class paths. And what's even better, that it can be picked up and exposed by third-party tooling, such as we promised, we will now show you how this can work with Spring Boot and namely with Spring Actuator. Let me get my app. So here is my application. Let me just zoom in, and maybe I can actually compile it so we have a fresh build. And in the meantime, I will tell you what it does. Just quickly pointing out that I'm running on GraalVM 23 already as my Java installation. So let's go ahead and let's compile it. Be native compile. And this will also cover the build times question. Now, so what is the app? The app is a Spring Boot application, pretty standard one, where we have our main class, and then we have our controller. And what is new here in my POM.xml, what I'm doing in native Maven plugin, and this is the plugin coming from our team, a part of our Build Tools project. We always recommend that you use our Maven or Gradle plugins, or if you're using frameworks such as this one, Spring Boot in this case, this plugin will be included for you as your GraalVM native image dependency. So what is different here is we are saying we want our SBOM to be both embedded and available on the class path. And another option we are doing here is we are saying we want to emit build report that we will show to you after the demo. Okay, let's see how our build is doing. I would say it's going quite okay. We are at the moment creating our image, and that's the last step. And overall, the build took 46 seconds. I would say this is quite okay. This is built with the -OB quick build mode, but overall the build would have been, I would say, around 1 minute or less on my machine. So let's go ahead and run this app, target demo, and it starts in 85 milliseconds. And then when we go to our browser, we get our message. And what is new about this app is that you can also go to the Spring Actuator. And here we can see our SBOM available in Spring Actuator. So how this works at the moment is that I have in my application properties file set a custom location to inform Spring where to look for my SBOM. But that will be also built-in support from the Spring team coming in the upcoming release. So this will work even without this one config line. But at the moment, you already can give it a try, and it's just one line away from you. So you can either explore your SBOM here, or you can also feed it into your vulnerability scanner of choice, and it will tell you about the dependencies and vulnerabilities in your application.
Well, and it's probably not the best idea to expose this endpoint to the web, right? But it's nice to have that available within your microservice landscape, so that you can scan your services while they are running for vulnerabilities, right? So that, I think that's the main intention, and you can pipe this into like a tool like Ripe or some other security tool and check for vulnerabilities and whether you need to redeploy any of your services.
Yes. So this is the new SBOM support in native image. And as you were talking about -OS, I think I also have a smaller version of this app available. Let's see. So this is my normal app, and this is optimized for size. In this case, the difference is maybe less prominent, but for some application, it will be up to 1/3. So if you want to have smaller executables, -OS, new flag available in the new release. With that, let me go back to our release blog post and talk about other features in this release. Just quickly telling you that the demo that I showed is also available and linked from our release blog post. You can give it a try yourself. Now, other thing in this release is that we have also an update to our build reports. So that was the emit build report flag in my POM.xml. And I even already have it open here. So we had build reports for a while now, because we also got that question in the Java stream. They were available before, but now we have a new option to generate them, and also the content of the build report is updated. So here you can see the summary of your build, see what we discovered about your application, what our analysis have found in your app, and then we can keep exploring even more is you can go into the code area. And here you can see a breakdown of all the packages and how they relate to each other and how they contribute to your application and its size, either by bytecode or by method count. And we have here a new tab that is the resources tab. Here you can see all the resources that are being pulled into your application. Mine is fairly small, but let's say you had some larger resources. This would be a place to find it and to discover it. Or on contrary,
No, go ahead. Sorry.
Yeah, I just wanted to add that either you can, for example, discover here that some resources were missing, so they should have been included in the application, but they were not there. So this might cause troubles at runtime. So this report will help you catch such cases. Go ahead, Fabio.
Yeah, I just wanted to add that it's a common problem that users run into, that maybe you create configuration for resources that is incorrect, and then you accidentally include something that you don't want to include, or you're not including the thing that you thought you would include, right? So now in this report, you can actually see what's going on. Sometimes I've seen users including binaries, really big files in their native executables, and then they're concerned why like the binaries are so big, or as Alina said, something is missing. You can see that here, that you registered something, but it wasn't found on disk. Right? And likewise, you can use those other tabs. For example, the code area tab that Alina briefly showed, there's actually a table underneath. So if you scroll down, there's like a list of all packages. So you can go through the contents of the code area in your image and find out like what is the dependency that you're using that pulls in a lot of code. And we keep improving this. This is actually interactive, so you can click on like org and then really dive into the code, right? And even up there, you can also like select, I don't know, Spring Framework, for example, or Boot, right? And you can delve into there and see what's going on in your image. In the image heap, you can also find objects that are, this is just code, but image heap is objects in your heap. So this app has a lot of code metadata. There's not much that you can do about that, but there's 6 megabytes of strings, right? So that application is quite string heavy apparently. And there's almost a megabyte of resources, for example. So if you have too many resources, you will see that here as well. But you wouldn't see which resources they are, and that's why we created this new tab. And I think, Alina, you wanted to show the SBOM tab.
Yeah, right? Yeah. In the meantime, I saw the comment that like the stream resolution is not that high. So I'm trying to see if this is something that I can fix either for my screen or no, I think this is the max we can go. But okay, let me see if I can zoom in and if that can make things better. Okay, got it. Bullet reports, and in the meantime, I wanted to answer other questions that we got. We were also asked if there are any plans to generate tips more quickly and automatically. Today, in applications that have certain dependencies, we use the native image agent to generate the tips. It's a good thing that you're using the agent. It's one of the recommended ways to go. Also, a good thing to check would be whether your dependency includes tips for hints for native image automatically. So it can be either included in your dependency or available in the reachability repo. You can check that on this page, ready for GraalVM native image. So those are many libraries and dependencies that support native image out of the box. If you are running
the last time we showed this, the list was much shorter, right? So this list
I think so. I keep tired of scrolling. Yes.
Yes. So there's a bunch of new libraries that are being added to this repository, both the shared metadata repository and libraries that bring their own native image metadata. So hopefully in the future, we'll have way fewer occasions where you need to run the tracing agent. Right, but yes, so far this is looking pretty good.
Yeah, and about automatic generation, I don't think that's ideal to enable the agent by default. When it comes to automatic detection, there is some that native image can do out of the box. So for example, some reflection calls, native image can figure out of the box. But if you're asking to enable the agent by default, I'm not sure that is ideal. I still think that manually triggering it when you actually need it might be the best way to go.
There's another question in the chat. Are we able to generate those reports in all our GraalVM versions? In the JDK 22 release, the previous release, that option was already there, but the build reports were experimental. In this release, we're actually adding, as you can see here, a public API option, -- emit build report. And those give you the latest features, including this new resources tab. So we highly recommend, of course, using the latest GraalVM release here.
Okay, let's see. We talked about build reports. Now we will get to the languages in a second, I think, Fabio, yes. Right? That's what we agreed on. Let's finish with the JDK and native image updates. So another update is that we are following many of the OpenJDK projects closely, and in this update, this release, we want to give you an update on the FFM support in native image. So some of it was already there. For example, the foreign memory functionality and down calls were available in the previous release, but now in this release, also the up calls are supported in native image. So we are always working to implement more and more of this support in GraalVM and in native image specifically. And there are also some other developer experience improvements in native image. So as again, with every release, we're trying to make sure that we are improving the developer experience for you. In this release, what is new is, for example, if you need to provide configuration for proxy classes, previously you would have done it in this proxy config JSON file, but now you can also do it in the reflection config file in case you need to provide this configuration manually. So now you can just do it from the reflection config, but we will still honor the proxy config configuration as well. And also, in case you need to specify the resources and specifically their location to be picked up by native image, we now added this new neat way to do it using the glob patterns. So now you can just do syntax like this if you want to specify all of those to be included. And a few other updates. So we also updated our option for building mostly static native images. So the ones that are statically linked against everything except for libc. Now the option that you will use will be -- static no libc. And some other updates. So native memory tracking, the memory that is used by the hotspot, but the runtime itself is coming to native image as well. There have been a nice contribution on GitHub from the Red Hat team to introduce initial support, and there are plans to also extend it in the future. We briefly mentioned the reachability repository. So this is the repository on GitHub, which is a centralized place to contribute, share, and then reuse necessary configuration for native image. We had a new release, and in particular, what this release added was support for Flyway, Hibernate Core, Hibernate Reactive, and other libraries. What is also really cool is that access to this reachability repository is enabled by default in our Maven and Gradle tools, and also the frameworks that are using our native build tools are picking this up automatically. So if you are using one of the libraries which contain config in this repository, that config will be picked up for you automatically from the repository. There is nothing to do from your side of things. And again, going back to that question that we had about build times and compilation times in native image. So you might know about one of big projects that we are working on in the native image space, and that is called native image layers. So we are working on a big new way to build native image applications where you can build shared libraries, so base applications for your app. Let's say I have a Micronaut application, so I can compile my JDK base, I can compile my Micronaut core, my Micronaut web maybe, and then every time I'm recompiling my application, I only recompile the code that I myself wrote, this thing layer on top of my dependencies, and this can give us much faster compilation times. We believe that they can go down to a matter of seconds. So this is a big project. As you can imagine, it requires a lot of work to happen because this is a brand new way to build native image applications. But we are actively working on it, and there are many updates coming up soon in this space, so stay tuned. And I want to switch here to more of community and ecosystem updates, and this one I'm personally very excited about. You might have seen this announcement from the Kafka stream where they are introducing official out-of-the-box support for native image and native image compilation. And in their proposal, they are saying that they did a lot of measurements, such as the ones we see on the chart here, and they observed significant improvements in startup times, memory usage, and CPU usage by running brokers as natively compiled applications. And I think this is really cool, as they are saying, for testing and development purposes, where maybe you want to have your brokers coming up more fast. But also, I believe in production, this could be a good way to have both better startup, but also lower memory usage. And I want to share some of the observations that I've made. So those numbers are coming from the lovely Kafka people themselves. And they say that startup time with brokers compiled with native image is just 1/9 of the JVM versions. And then there are no CPU spikes in the native image because there is no compilation happening as your application runs. And also memory usage, they are saying, is one of more significant metrics there as well. And they notice that for native image, if you're running with G1GC, memory goes down by 2x to just 500 megabytes. And then if you switch to serial GC, memory comparing to running on the JVM goes down even by 4x to just 250 megabytes. So this is very cool. And again, I know a lot of people in the community who are very excited about this update and already sharing blog posts and conference talk about it. So I'm also very excited about this. How are we doing on questions? Fabio, do you want to take one about the layers or?
Yeah, there was one about the layers, how they work.
But
We're not doing a closed world assumption anymore. Those are open world images. But I don't want to bore you with all the details. You can read them all up on the roadmap. The way these images work is a bit different, but it will improve horizontal scaling of your application, and also, like, most importantly for the development experience, it will allow incremental builds, right? So that's a nice feature. I posted the link to the roadmap item in the chat. So
yes.
There's one big thing that you want to talk about, right?
Yes, very exciting. And some people already actually noticed it and made suggestions in the comments. So we want to show you our brand new GraalVM community mascot. You can check them out on our Medium. I think they look super cool. So you can think of them as kind of a friend of Java's Duke. Maybe you want to showcase in your blog post, in your conference talk, in your demo that this is running on GraalVM. So this cute mascot is something you can use, and better yet, you can modify them. So you can maybe, I don't know, extend them with your library logo or make a cool Rockstar version of them or something. So it gives you way more flexibility, and there are many
Are you still there? You muted? I can see you, but I cannot hear you. It looks like you're muted.
Okay.
Let me unmute.
Yeah.
I just unmuted you.
I thought
Okay.
I was muted.
I don't know what happened.
Anyway, thanks for the help. I have two mics, so apparently they're conflicting. But anyway, if you can hear me, it's all okay. It's bad though that it interrupted me and the most important announcement. So our mascot is still looking for the name. This is the community mascot, so we want to give our community a chance to name them. So you can drop a suggestion for us either in this live stream, or we'll probably do a poll on Twitter where you can suggest all the names. There are some suggestions already in the comments, I believe. How do I see them? Like Gracie, I think, as in Graal and community. I really like this one. But if you have other ideas, let us know and help us name our mascot together. With that, let's switch to, let me see. Yeah, we have more community updates. I want to cover this quickly. So in the community space, our key repo, Oracle Graal, has reached 20K stars on GitHub. So thank you so much for your attention, but also your help and your feedback and your contributions. You have made this happen, so we are very grateful. And in other community updates, we this week have GraalVM Community Summit here in Zurich. So we will talk to our partners and contributors about where we are and what is coming up next for GraalVM. And we also have been asked to share some kind of summary online. So we will make sure to do that. And a few other updates. So I'd like to feature this one from the State of Spring, where they asked their users, so the Spring users, how many of them are using GraalVM and how exactly. And they said that 11% of the Spring Boot users already run GraalVM natively compiled applications in production, and 26% of the users are currently evaluating, and 31% more are planning to develop native image applications with GraalVM. So this is very cool, and this makes me very happy because we see that the features and the things that we are working on are actually being used by people in production. And there are more community updates, but also we want to switch to another big topic today that we have, and that is the Graal languages. And with that, I will take off my screen and I will bring up Fabio's screen.
Yes, thank you very much, Alina. So yeah, for the languages, We haven't been talking about them much in the last couple of releases, but there's a big exciting update in this release. The big announcement is that GraalPy and GraalWasm, our Python and WebAssembly runtimes, are no longer considered experimental. They're now stable, and you can actually get support for them if you need it from, as part of Oracle GraalVM. We have prioritized pure Python code and Jython code, or Jython use cases for GraalPy. And there's lots of cool things going on in GraalPy at the moment that I would like to show you. Right, so maybe I'll switch over to the website. So on our website, from like the landing page, you can navigate to our languages just by going via the Graal project switch. And GraalPy is now this is now the new landing page, and GraalPy is our embeddable Python runtime that you can embed in your Java applications. It's Python 3 compatible, right? And likewise, we have GraalWasm here, and there's other Graal languages. GraalJS has already been supported for quite some time, and WebAssembly, we're going to talk about that in just a second. So what do you need to do to use these languages? Well, it's actually just 2 additional dependencies that you need to add to your either Maven or Gradle configuration, right? And once you've done that, you can just program against our context API, create a new context, and then evaluate code. Well, this is just a really simple hello world, of course. But if you want to do something more sophisticated, for example, using a specific Python package, what you need to do is also add another plugin. We have a Maven plugin in this release, in the CPU update release in next month in October 24.1.1. We're also shipping a Gradle plugin that can do the same. And here you can specify additional Python dependencies that you would like to have available in your Java application. So one thing that that I already mentioned is that we currently prioritize pure Python code and Jython use cases. So if you want to migrate from Jython to GraalPy, today is actually a really good day because it's I think further down below, but there's a new option called Emulate Jython, which emulates the Jython behavior. If you rely on this, you can turn it on and makes migration easier. But of course, you don't need that. What you may run into though is if you're using packages, for example, NumPy or scikit-learn or Torch, they are using native extensions, and many of them work. But we still consider them experimental. So you will get a warning in the in your terminal or wherever you run your application if you happen to use one of these native extensions. Well, these native extensions, they are a bit problematic in that sense that they are specific to, they need to be compiled against the Python interpreter. So right now you need to actually build them from source for many packages. And that can be, depending on the project, require quite some work on your end. Well, actually, in this release, we are also adding a new PyPI repository for GraalPy. So this is the default now. So if you're installing some packages, and this literally just went live, right? So this is really hot from the desk. So if you're installing one of these packages that happen to be in this Wheels repository, instead of having to build from source, GraalPy will actually fetch the binaries built for GraalPy, and we're working with the community. The Python community, to extend Python packages with GraalPy wheels so that they will ship wheels out of the box. So feel free to reach out to Python package maintainers if you want to use their Python packages on GraalPy and ask them to test and build wheels for GraalPy. And we're happy to help, right? So feel free to reach out if there's anything that we can help with. So that leads me to the first demo. I briefly shown this at the Java stream. So what I have running here is actually not, I need to check because I have this in 2 versions. This is not the Micronaut version that I showed at the Java stream. This is actually the Spring version. So this is a little tool that uses Veda sentiment, a Python package, and to analyze text and to analyze the sentiment. So I can say things like the new GraalPy release is not bad at all, right? And it will respond with a smiley because not bad at all is actually pretty good, right? So
can we say something more exciting, like GraalVM is awesome or something, and see if we can get it more exciting?
Is awesome. Yes, well, it thinks it's funny. Live demos make me nervous sometimes, right? And this is running live on my computer. So yeah, that's a bit negative. And it can even see things like, don't forget to smile, right? And I'm using emojis here and it detects emojis. So this is really, really simple. And if you're checking out Veda sentiment, and we're also going to share these demos on GitHub so you can try them out soon, you will find out that there's not much to this to make this work. And I also want to quickly show you how that works in Spring. So this is my demo controller of the app that I'm just running here, and it has this index page, and that serves a template. And then there's also this analyze endpoint, and that is using the sentiment analysis service, which has a get sentiment score. So if we're looking into this is actually, I didn't set up my my environment right. So let's see, can I quickly add this? Well, it's supposed to be here. So let me try and add this again. Maybe it will pick it up. Maybe it won't. Doesn't matter. So yeah, it's a bit confused right now because it thinks this is not installed on my machine, but it actually is. And I'm just using the wrong Python interpreter at the moment. So this is the Python source that you can find on the website. This just creates the sentiment intensity analyzer. And I actually evaluate this in this context, like you've seen in the Hello World example on the website. But what you can do is you can say, I want this as an interface. And here I have defined a simple Java interface, and I can program against that Java interface. And this sentiment intensity analyzer has this polarity scores method. Well, you can tell because this is snake case, this is Python, right? And that's what we're calling here. So you can just program against Java interfaces, even though you're using a Python a Python package. And that's it, right? The creation of the context is really simple. We just create a new context. We initialize Python so that we're doing this at startup, and we're just making sure that we're closing everything nicely when we're shutting down the service.
But also, I specifically appreciate how easy the setup is, because if anyone listening to us, I would try to set up a polyglot project that can be complicated, right? And here we are just staying in the normal Java space and doing normal Java things, such as specifying this as Maven dependencies, pulling them from POM.xml, and that is all that you need to do to have this available to you. And we kind of had a similar question in the Java stream. So is this using CPython underneath, or like what is going on? But not, this is using GraalPy. And all the setup that you need to do is, again, your normal Java POM.xml, where you're adding 2 dependencies, and you can start using Python from Java.
Yeah, you may have noticed that I'm using Grail in this project. Well, sometimes I use Maven, sometimes I use Gradle, sometimes I use both for the demos.
We love them both. No personal preference. No preference there. We can use both.
Yeah, but I also mentioned that 24.1.1 is not out yet, but I of course built it from source, so we can test this out. So this extension will actually ship in October. So I add the plugin. I say I want the Polyglot API, which provides me with this context and engine and other things from the Polyglot API, and that's how I enable Python essentially. And then here, this is what I do. I just say I want these dependencies, for example, Veda sentiment and transitive dependencies, because I like to lock my versions nicely. Okay, so let's move on to the next demo. So this was really simple. I just want to give you another impression what you can do with GraalPy. So here's this PyGraal package. It's actually written in pure Python, so no native extensions at all. You can just use that on GraalPy, no problems. And it generates lots of cool visualizations. So if we take the XY chart as an example. This is an interactive XY chart that you can program in Python, and that's the Python code, right? So let me show you what that looks like. I've turned this into, well, here now I'm running a Micronaut service. So I'm hitting the Python endpoint, and if I refresh, so that's the service, it's up and it's serving me that example that we've just seen. So actually here I can also go to Java, I can go to mixed, and there's also dynamic. Not sure we're going to show that, but all of these graphics are identical, right? I even wrote a test that makes sure that they are identical. The only difference is their implementation, right? So let's take a quick look at the implementation. This is the demo controller for that example. And here's the Python endpoint, the Java endpoint, the mixed endpoint, and the dynamic endpoint. So if we're looking at the Python endpoint, the one I started with, it's using this PyGraal service, pure Python, and then it just renders XY chart, right? So if we are looking at the implementation, what you can see, and here the language injections are actually working and it's all picking it up. So this should provide me with nice auto-completion and documentation in Python, because IntelliJ is really cool, right? And it lets us do these things. So here I just evaluate the whole example and then say, I don't want it as an interface, I just want it as a string, because the result is supposed to be a string, and then I store the string, and then I always serve the same string. So that's really trivial, right? But we're Java developers, right? We want to program against Java interfaces and use Java as much as we can. So that's what this pure Java service can do. So what we are looking at here is the implementation of the same example, but we're using the PyGraal module directly as if it was a Java object. And then we set the title and add some data points. I even converted the Python expressions to proper Java expressions for cosinus, for example, right? And then we just render the chart and decode the chart, because the rendering returns actually a byte IO object, and then we want a string, a Java string back, and that's how this works. So up here are the interfaces that I needed to declare for this. Of course, the PyGraal interface is probably much bigger. I only implemented what I actually needed. And when I start using this PyGraal module, all I do is I import the PyGraal module, and then I retrieve the PyGraal module, and then I say I want this as this PyGraal interface, right? So that's the whole magic. So that means you would need to write all these interfaces if you want to use that approach. We're actually working on an interface generator which will help you do that in the future. And then moving on to the mixed example. The mixed example is doing both. It actually has the data in Java. So this is a Java string and a list of entries. And the entries are actually like a proper Java record, right? And what we're doing here is we're calling a Python function and execute it with the title and the list of entries. And then we expect the result to be a string again. And up here is the implementation. So we import the PyGraal module, and then we define a new function. And that function takes the title and the label data point entries, and then it does what it needs to do and returns the result. And the result of this evaluation actually returns a handle to that function. Right. So what I just want to show you here is that you can choose what parts of your application is on the Python side and what's on the Java side.
So Fabio, in the meantime, we got 2 questions, if you don't mind, kind of asking the same thing, but people are very excited about this. And I think you and I like this question a lot. So people are asking, such polyglot applications, such the ones that you are showing, can they be compiled to a native image? And the answer is yes, that is the best part. So what Fabio is showing to you is actually can also be compiled to native image. And I believe one of his demos at least is actually a native image.
Yes.
So yeah, the dynamically executed languages will be still dynamically executed at the runtime, but you can compile the whole thing, the Java base, into a native executable, and then have this polyglot running at runtime.
Yeah, well, all our languages are open source, and they're coming from the GraalVM team, right? So we are, of course, making sure they work really nicely with native image. There can be some rough edges, but let us know if you're running into any problems, and we are happy to take a look. So if you don't want to use an interface, you can actually directly program against the value API. That is part of the polyglot package. So this is what this dynamic endpoint does. It does the same thing, but not as nicely, arguably, because it's like invoke dynamic, right? So like we're invoking a method called add, we're invoking a member, or we're putting a member called title, right? So that's also something that you could do, but yeah, just for completeness, I wanted to show that in this demo. Okay, well, then there's more. We mentioned JavaScript, right? So if we're scrolling down in the blog post, the new updates for JavaScript is actually that the JavaScript WebAssembly API is now stable, which is really cool. So you can call from JavaScript to WebAssembly and use WebAssembly. We also implemented support for ECMAScript 2024. And that is now turned on by default. And we implemented several new proposals like resizable and growable array buffers. And there's some pretty cool news in that area as well. So if you go into the landing page, you'll find all the benefits and everything that you need to do to get a hello world going. There's some use cases, for example, server-side rendering in Micronaut and IntelliJ. So IntelliJ, if you're using IntelliJ, the latest version actually is now shipping an HTTP client that you can use inside the IDE, which is using GraalJS under the hood, which is I think a really cool thing, of course. So that is I think they migrated off I think Nashorn or something. So if you're running Nashorn still, consider using GraalJS and migrate, because here you can use the latest ECMAScript. So they are using ECMAScript 2023, but 2024 is out today. And then I already briefly mentioned Micronaut. So Micronaut has this new feature, React server-side rendering. This is actually JavaScript React that you can use to render React templates in Micronaut. And it all runs on GraalJS. So if you go into Micronaut and you're adding new features, you can search for GraalJS and you will find that React component and you can add that. And if you're previewing the application, it will actually come with like a view component that you can render. And this is all set up. Like I just download this and I run it on the JDK, on the JVM, or run it and compile it to native. It just works. So this is a new preview feature. I believe it's experimental, but this is something that we are going to continue and work on. And now, last but not least, WebAssembly. WebAssembly is also on the website. It is embeddable in Java. What a surprise. And it's compatible with WebAssembly 1.0. So you can actually find GraalVM on the website. It's rendering. It's rendering on the features extension website. So you can see all the features that are currently implemented by GraalVM alongside the other WASM runtimes. And yeah, again, two dependencies, right? You need a WASM module though. So this is really simple add to example. And then you can use the context API and program against WASM, the WASM module. So, well, WASM is very low level and you need to program against like, I don't know, an I32, right? So you want to do something more exciting maybe and use an image as an example. So as a demo, I quickly want to show you an image processing library called Photon. And Photon is actually written in Rust and it compiles to WebAssembly. Further down on that page, you will find a demo. So this actually runs in my browser and modifies the image. So you can choose different effects, or you can flip the image, right? And here, and I have a service running. This is actually Micronaut native. So this is a native image with G1. It's PGO'd, everything, right? And it runs with this Photon module embedded on GraalVM using the JavaScript API wrappers through that JavaScript WebAssembly API, and then Java, or the Micronaut application, is talking to the JavaScript wrapper, right? So it's Java to JavaScript to WebAssembly and back, right? And this is the default filter, which doesn't do anything, but I can choose a different filter, for example, grayscale, and then I get a grayscale version of that image, or I can choose flip V, which flips the image vertically, or I think there's something like colorize, which colorizes the picture, right? So this is all running in native image, but also I can quickly show you the code. So at no surprise, there's an endpoint. I don't know what's going on with my IntelliJ. Here's the photo endpoint, and it takes an effect name, and then it uses this photon service. And this is how it works. Well, actually, because those request handlers are handled in by multiple threads, we actually use a pool. So we have multiple instances of this photon module, and every time a thread responds to a request, it will take a photon object from this photon pool. We don't need to look into details. Again, this will be up on GitHub. You will be able to take a look. So, and then this photon module has an implements effect. So we can ask it, do you implement the effect? And if that's not the case, we return a not found. Otherwise, we create a new image. We apply the effect that was chosen by the user, and then we turn that image back into a byte array. We need to free the image, and then we return the byte array and put the photon object back into the pool. So none of this is really JavaScript code or WebAssembly code. I think it looks pretty good for a demo, at least. I'm sure you can come up with better solutions. But this demo is already available in the GraalVM demos repository, I think. Okay, do we have any questions? Are there more questions?
No, not at the moment, but we can give people maybe a few more minutes to ask any questions that they might have to us. In the meantime, we can take a look at other updates in this release blog post. People can read more on Medium. One thing that I want to specifically mention is that virtual threads are also available for Graal languages now. So you could have used them for your Java applications or native image applications, but now they also came to Graal languages. Even though the support is experimental at the moment, you can already give them a try. And I know that many people in our languages community will be very happy about this update.
Yep. And Mike also had a blog post on our blog about writing truly memory-safe JIT compilers. If you're interested in how Graal languages work under the hood and why they're different to, for example, V8, how GraalJS is different to V8, take a look at the blog post. I already mentioned IntelliJ IDEA is using GraalJS under the hood. There's also a new language from Apple, which is based on our truffle framework, which is called Pickle, right? And I think we're at the end of the blog post, right?
Yes, and we are also at the end of the 1 hour that we promised people that we will try to make work. So again, if you have any question, you have maybe 1 or 2 minutes to ask them as we wrap up. But other than that, go to graalvm.org, get the new GraalVM, try it, run with your applications, let us know what you think. And if you are waiting for the SDK man availability as we are, if you know SDK man guys, they're already working on this, so that should come up very soon, we think. Other than that, go to the website, download GraalVM, give it a try.
Okay, I don't see any more questions in the chat. I hope the chat is still working.
No, it seems good. And I see some reactions flying in. So I think the chat is still okay. If you have any questions, though, after we finish the stream, you might know that we have many community platforms. You can always ask us questions on GitHub. We have a very active, huge Slack workspace for our community with like 4,000 members. That's a good place to ask your questions, or on social media or on GitHub. Many places where it works for you, we will be happy to help you. And if you want to try the demos that we showed to you today, they will be available on GitHub in GraalVM/GraalVM demos.
Yeah, and Johan makes a good point. Well, I'm looking forward to meeting you in Antwerp. Alina and I will be at DevOps in 2 or 3 weeks, right? And well, this week we actually have the GraalVM Community Summit. I'm also looking forward to meeting some of the people here in the chat in person and discuss the future of GraalVM. Feel free to reach out to us on Slack, on X, on Mastodon, on LinkedIn, or come and meet us at DevOps and join us for our talks, right? So Alina will be talking about native image, and I'll be showing some more Graal languages demos.
Yes. So looking forward to meeting you all in person or online if you have any questions or comments. And thank you so much for joining our stream.